Now, we use arrangements for sports all the time. All right, so here's a couple of sports analogies. Sorry for people who don't really like the sports analogies. You got 5 starting basketball players for any basketball game. In how many different orders, which is another way of saying arrangement, could you have them announced at the beginning of the game? Well, you're doing 5 different events, and the first time you have 5 options because you got 5 people. This number is going to be bigger than you think, by the way. And then the second time, you have 4 people left. The third time, you have 3 people left. The fourth time, there's only 2 people left. And the last time, there's only 1 person left. And the multiplication principle says, multiply all these together. For those 5 people, there are 120 different orders that I could have them arranged. Okay, next example. You have 9 starters for a baseball team. How many different batting orders are there? You guys, it's the same question. It's just a bigger number now. So I got to pick somebody first. I got 9 people to choose from. I got to pick somebody to bat second. There are 8 people to choose from. And then 7, and then 6, and then 5, and then 4, 3, 2, and 1. This is going to be a number that you think is way too big, but it's true. For 9 baseball players, there are 362,880 different batting orders. Okay, you have 6 different textbooks in your locker for 6 different classes, as if you guys use lockers at this point in life. And how many different orders can you stack them? Can you guys see this is the same problem again? This is 6 times 5 times 4 times 3 times 2 times 1. And if I have 6 textbooks, the amount of different ways I could stack them is 720 if I multiply all those together. Okay, so notice there's a pattern going on here. You guys may have seen it before. Sometimes I teach this, nobody's seen it before, so, I don't know. For any positive integer n, the notation n with an exclamation point. That's a notation just like having an exponent, or a square root sign. The exclamation point means factorial. It's called n factorial. And it suggests the following computation. N, like this 5 or this 9 or this 6, and then what did I multiply by? The next number smaller, right? Now, how do I write that after n? It's easy to subtract 1 and go from 6 to 5 or 5 to 4, but what I write here is n minus 1 as the second number, And then the next one would be n minus 2. 6 minus 2 is 4. 9 minus 2 is 7. 5 minus 2 is 3. And then I'm just going to do a dot, dot, dot until I get to 3 to 2 to 1. That's what a factorial is. N factorial is n times all the integers in front of it. So 3 factorial is just 3 times 2 times 1. It's equal to 6. There's a button on your calculator that does it for you. Ready? Let's go with this 9 thing, just in case you guys think I'm lying. 9 factorial, 9, and then you hit your math button, and somewhere, maybe over in probability, there it is, there's a little exclamation point, and it is 362,880 different batting orders. All right, next page. Oh, now we're going to get to a big number. Oh my goodness, you're not going to believe this. I'm telling you, you're not going to believe it. Baseball teams don't just have 9 players, they got 22 players on a team, and they only have 9 playing at the time. So, how many possible lineups could there be? If you got 22 players to pick from, you got to pick 9. It will go like this. 22 options for the first batter. And then once you pick one, you're sampling without replacement, so you have 21 batters for the second player. And 20, and 19, and 18, and 17, and 16, and 15, and 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I stop. I don't keep going because I only got 9 spots. The other 13 people are left out. They're on the bench. Maybe they come in later on in the game. If you type this into your calculator, you get this. Are you ready? 180 billion 503 million 769,600 different lineups from 22 players if you're picking 9 people to bat. Yeah. Simplify the following expression. 6 factorial over 3 factorial. Okay, I'm going to write it out. 6 times 5 times 4 times 3 times 2 times 1, and it goes over 3 factorial, which is 3 times 2 times 1. Okay, now these are all multiplied, so canceling is in play here. And don't all 3 of these cancel with all 3 of these and just leave you with 6 times 5 times 4. Right? Well, this was like 22 all the way down to 1, and then it was divided by 13 down to 1, and the 13 to 1 canceled with these and left me with that in the numerator, just like the 3, 2, and 1 canceled and left me with 6 and 5 and 4 in the numerator. So in the baseball example with 22 players, I could write it as 22 factorial over 13 factorial. And I could do this with my calculator. 22 math probability. I think there's a quicker way to get to that thing, but I don't remember. 22 factorial divided by 13 factorial. Let me go find it again. And there's your number. Now this e to the 11, of course, means move this decimal place since it's positive 11 spots to the right. So if it's in between the 1 and 8, watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you thought I was lying. You think you'd never learn. Okay, so here's our definition for today. The number of ways we can arrange n items if we take them k at a time. Like n equals 22 baseball players, and k equals, I need 9 of them at a time. This is called a permutation, like we had on the other page of the notes, and it can be found with the following expression. This is going to look weird. The n and the k are subscript numbers, okay? Sub n and then p sub k. If I was typing them, like in Word, I would use subscript. N, p, k, n things taken, a permutation of n things taken k at a time is equal to n factorial over n minus k factorial. Let that sink in for a second. Look, if I have 22 baseball players and I'm taking 9 of them, what is 22 minus 9? It's 13. That's where I started cutting these off. See what I mean? Okay. Of course, if it's n things just chosen n at a time, the expression is just n factorial. Okay, and so let's put another asterisk right there. Of course, it's just n factorial, like the basketball player thing, 5 times when you're announcing all of them. But look, if I use that formula though, look at what this means. I'll make a little cloud here. That means n factorial over n minus n factorial is equal to n factorial. So what I'm getting at here, that means 0 factorial has to equal 1. Okay, so if you've never seen factorials before, that's new. It's kind of like raising anything to the 0 power is 1. You're just sort of canceling it out. And if you're canceling it out in multiplication, you're left with a 1. Okay, so we have a book example on page 315. We're supposed to look at number 1. 315, number 1. All right. You'd think I'd have the book open since I knew I was going to this thing. Just number 1, eh? Okay. The local ice cream shop in my man Dontrell's town is called 21 Choices. Why? Because they offer 21 different flavors of ice cream. Fascinating. Dontrell likes all but 3 of the flavors that 21 Choices offers. Bubblegum, butter pecan, and pistachio. This is just riveting reading here. Number 1, a 21 Choices basic sundae comes in 3 sizes, small, medium, and large, and includes 1 flavor of ice cream and 1 of 12 toppings. Dontrell has enough money for a small or medium basic sundae. How many different sundaes could Dontrell order that include only flavors that he likes? Wow, that's a lot to take in. It comes in 3 sizes. He can only buy a small or a medium. All right, so he's out on the largest. So small or medium. So I think what I want to do here is I want to go, you guys, okay, let's talk about how dumb I am. That's page 313. And this says page 315, and I kind of hate myself right now. But you know what? I'm going to do it anyway. So, small or medium. So, as far as size of what he can order go, there's only 2 possibilities. Then what happens after that? Enough money to buy medium. So, how many sundaes could he get? Well, what else happens? It includes 1 flavor of ice cream and 1 of 12 toppings. They got 21, and he doesn't like 3 of them. So, that's 18, right? So there's 18 different flavors, and there's 12 different toppings. So he could go 18 different flavors. He could go 12 toppings. And so I need to multiply 2 for the 2 different sizes this guy could get Annoying guy, Don Trell. Forget about him being my guy anymore. 2 times 18 times 12 is 432. Don Trell has 432 different options. That's a 3. Get over it. So 315 number 1. Let's see what that has to say. A standard issue 2014 New Jersey license plate had 3 digits followed by 3 letters. These plates were not allowed to have letters D, T, or X in the 4th position. D, T, or X, you can't have it right there apparently. Or the letters I, O, or Q in any position. What the hell? With these restrictions, how many license plates are possible? Okay. Not allowed to have those. Okay, so in the first place, you got a digit, so that's going to be 10 for the first digit. The second one's a digit, 10 for the second digit, and 10 for the third digit. Now we get to this 4th digit, and Texas gets all, or New Jersey gets all weird. You can't have a D, T, or X, and you can't have an I, O, or Q in any position, so we're taking away 6 letters in this spot. That means there's 20. There's 26 letters. I can't use D, T, or X in that spot, and I can't use I, O, or Q anywhere, so I got to take 6 away. Now, the last 2 spots, I can't have an I, O, or Q, so that's 23 times 23. Well, that's a lot of stupid going on in this problem, but it's doable, right? 3 10s, a 20, and 2 23s. 10 times 10 times 10. Of course, we could use exponents for some of this, right? Times 20 times 23 times 23. And that's a whole lot of, and there's 4 zeros here. That's a whole lot of license plates. It's 10,580,000 license plates. Ooh, that was exciting. Okay, next page.